Why is it
All right,
frozen?
me and Antonio are sitting here. We're going to review with you these questions to help you with you know your skills for taking the solutions exam. See Antonio right behind me here. He said you should go to this website, watch this video, listen to the song. He thinks you'll like it. What do you say?
Yeah, you should. You're gonna like it.
All right, well, do it. Question number 7. What is the total mass of KNO3 that must be dissolved in 50 grams of water at 60 degrees Celsius to make a saturated solution? Now for this one, we need to inspect table G. And which line were we looking at? We're looking at KNO3. Okay, so KNO3. Which line is KNO3? Where are you? There you are. KNO3 is right here. All right, and the temperature that we need to inspect. We need to inspect 60 degrees Celsius. So, KNO3 at 60 degrees Celsius. KNO3, let's move this a little bit, 60 degrees. 60 degrees Celsius. There we go. It's letting me pick the pen now. All right. So travel up the line until we reach KNO3. Now that lands roughly right here. Transfer over, and that would read roughly 105 grams of potassium nitrate, if it were in 100 grams of water. But the reality is it's not in 100 grams of water, it is in 50 grams of water. So to be saturated in 50 grams of water is not 105, it would be half that amount. So we would be looking for roughly 52.5. Now let's see what choices match. Now remember I said 52.5. Just deleting all these. Okay, now we can see the question. Now remember I said 52.5? Okay. That was based on an estimate, so the best answer here is 53. All right, number 8. An unsaturated solution. Right. If you listen to the song that I asked you to play, unsaturated would be under the line, and what did Mark Rosengarten say? You could put more in. All right, so an unsaturated solution is formed when 80 grams of salt is dissolved in 100 grams of water at 40 degrees Celsius. This salt could be, now please don't get confused, it's saying salt. It is not saying table salt, which is NaCl. Remember, any salt means an ionic substance. All right? All 4 of these are considered salts, just not the one you put on your French fries. So which one of these is the potential answer? We are looking for, let me write it to the side this time, at 80 grams, 40 degrees Celsius. We're dealing with in 100 grams of water. All right, so we're not going to have to consider 50 grams or 200 grams. That's not going to be part of it. And we're looking for unsaturated, so we want to be under. Yes, and that is a D, under the line. So, which one fits? We're dealing with potassium chloride, potassium nitrate, sodium chloride, and sodium nitrate. So, let's circle which ones these are. We are dealing with, let's start first with potassium chloride. It's right there. We're dealing with 40 degrees and 80 grams. So we're hoping that that point is under one of the lines. Potassium chloride, down here cannot be. Potassium nitrate. Okay, here we go. There it is. This one. Nope, the dot's still over the line. Sodium chloride, didn't mean to circle it like it's correct. Sodium chloride is, where is that line? NaCl right here. No, definitely above. Now let's inspect sodium nitrate. There's that line, following it through. This dot here, 80 grams at 40 degrees Celsius, is below this line. Unsaturated, choice 4. Number 9. The molarity of an aqueous solution of NaCl is defined as aqueous solution. Let's dig into that just a little bit. NaCl, aqueous. What this implies, because it says aqueous, is the sodium chloride is dissolved into water. So molarity is talking about a concentration. If we were to inspect our reference table, okay, table T, we would see one of our options for concentration is molarity, and it is defined as the moles of solute over liters of the entire solution. The solution is with the solutes and the solvent together. So this one is just the solute. This one is the liters of solution. You might have to convert from milliliters to liters or what have you, but it's extremely important that you realize that you can find this formula right on table T. Other things that might be important are another measure of concentration is parts per million. And believe it or not, another way you could measure concentration is percent composition by mass. Keep this in mind for the reagents. So which one is related to the definition? And grams of sodium chloride per liter? Nope. Grams? No, we're talking about moles. So moles of sodium chloride per liter of water? Now, water is just the solvent. Choice 4, moles of sodium chloride, which is the solute per liter of the entire solution. Number 10. What is the molarity? So once again, a concentration question. What is the molarity of 1.5 liters of an aqueous solution? So there's an entire solution, 1.5 liters of an aqueous solution that contains 52 grams of lithium fluoride, that is LiF, and lithium fluoride has a gram formula mass of 26 grams per mole. Now please remember from the last question, our definition of molarity is, let's zoom in a little bit more, is the moles of, here it is, grab my pointer, the moles of the solute over liters solution. But what was given to us is not moles of solute. What was given to us is the mass, the given mass, and the gram formula mass. And from that we could devise how many moles of solute we have. Let's get busy on this. Okay, put this aside. What are we given? We are given 1.5 liters of aqueous solution. Great, but that's for the second part. We need to know the moles of solute first. So we have 52 grams of lithium fluoride, but only 1 mole is equal to 26 grams. So we have the moles is equal to the 52 grams that we have divided by the 26 grams per mole that it is. Again, this states that every 1 mole is 26 grams. So how many moles do we have? Well, 52 divided by 26 is 2 moles. Now we could use the other formula. We could say the molarity, which is capital M, is equal to 2 moles of the solute divided by 1.5. 2 divided by 1.5. Is that number going to be greater than 1 or less than 1? Well, 2 divided by 2 is 1. If I divided 2 by 4, it would be less than 1. So I know that it's going to be greater than 1. So choice 4 is out. Okay, 2 divided by 1.5, that's pretty darn close to itself. So it's going to be choice number 1. If you don't believe me, pause, use your calculator. Get back to me on that. Number 11. Which type of concentration is calculated when the grams of solute is divided by the grams of solution and the result is multiplied by 1 million? Let's inspect table T again. Table T. There we go. Now we can look at table T. Concentration. The mass of the solute divided by the mass of the entire solution multiplied by 1,000,000 parts per million. Choice. Choose. Number 12. Which solution has the highest boiling point at standard pressure? Now, this question is asking you to consider the term colligative properties, which, if you remember, states that as particles dissolve in water, the freezing point will be suppressed and the boiling point will be raised. Now, this occurs because you don't have water alone anymore. You now have particles standing in the way of the interactions of water to water. So we need to investigate these 4 choices and look for the one that breaks up into the most particles. So let's inspect it a little bit more closely. When we take a look at 0.1 of potassium chloride, this substance will break right there, will dissociate when it hits water. So we will end up with 0.1 of potassium, 0.1 of chlorine, for a total of 0.2. Now that relates to the moles of the solution. And remember, moles is about a quantity. Okay, next we have 0.1 mole of K2SO4. Well, this one will break right here. But the potassium, it has 2. It will be 2 individual potassium. So 0.1 potassium, 0.1 potassium, and 0.1 SO4 for a total of 0.3 moles. So let me circle these, make it easier for comparison. All right, next, 0.1 mole of K3PO4. Well, how many potassiums do we have? 3. So just like in number 2, it becomes 3 separate potassiums. In an interest of saving space, it will be 0.3 from the potassium and 0.1 from the phosphate, from the PO4, giving us a grand total of 0.4. Circle it for comparison. And lastly, here we have 0.1 of potassium nitrate. This one will split right here, forming 0.1 of potassium and 0.1 of nitrate for a grand total of 0.2. Circle it for comparison. Which one is going to give the most particles? And that would then be choice 3. Okay, well that's great if the gram formula mass was given, but what if it wasn't? So let's take it consideration of NaCl. What is the gram formula mass of NaCl? Well, we have 1 sodium, 1 chlorine. We take the mass of 1 sodium is 23, and the mass of 1 chlorine, which is 35, and we get 58 grams per mole.